Here's a small tutorial on how to build a pretty sturdy shelf on a cinder block wall. So first thing you're going to need are these tapcons. I'm using 2 3/4 because I'm using some 2x4 and I want to have enough meat to go into the cinder block. And you're also going to need this masonry bit. Usually you'll find them right next to one another in a Home Depot. For fastening the wood together, I have these exterior screws, 2.5 inch by and also 1 5/8. Next thing I'm doing here is I am putting up, marking where on the cinder block I'm going to be drilling into, and I'm marking on my wood because I'm going to do some pilot holes. Alright, and then I'm going to straighten out all those marks that I made and find center, and I'm going to go ahead and drill. And the drill size I'm using is about roughly the same size as the diameter of the tapcon I'm using, because I'm not really trying to screw into the wood so much as screw into the cinder block. And I really want to feel the cinder block and make sure I don't strip it out. So my drill bit's about 30 seconds less than the actual size of the tapcon. Alright, and so once I'm done here, I'm going to wipe all this crud off. And I'm going to now make sure the masonry bit is going to reach the depth that the tapcon requires, and it does. And then I'm going to level off this piece of wood that I'm putting up here, and I'm going to go ahead and start making the, with the masonry bit, making the holes into the cinder block. You're going to want to go slow, and one thing I do is I have a little cup of water right there, and I keep cooling the bit off because I don't want to burn my bit up, because I'm going to have to make quite a few holes. After I get 2 pilot holes made, I go ahead and put 2 tapcons in those boards, and I finish it off, drilling all the rest of the holes, and then I take it down, put some of this liquid nails on. And once I get that on, I go ahead and put the board back up and finish off putting the rest of the 6 tapcons that I have in there. And you can see how strong it is. I'm sitting there putting all 210 pounds of me on it. And here I'm going to make those cross members for the shelf. And I got to make it nice straight, so I'm going to go ahead and cut this little end off just in case there's any incongruities with it. And after I get that cut off, I'm going to measure these out, and I'm going to do 4 cross members. And I know a lot of people like to have 24-inch spacing. I'm doing 32-inch spacing. You can make an extra cross member and keep it at 24, but I'm happy with 32. All right, you see it's nice and flush, and now I can come back 14 inches. I can mark that right there, and I'm going to repeat this process about 4 more times, or actually 3 more times now. And I'm going to have 4 really nice straight boards. Alright, so now that I got that cut, check 14 inches, and then I'm going to repeat the process 3 more times to get 4 of them. Along with another 2x4, I can complete the frame, and then I'm going to make 3 braces on the wall, making sure they're level, and then I'm going to start on the braces going out to the edge. Okay, so you may be thinking, how the hell am I getting these angles since I'm not going through regular 45? Well, what I'm going to show you here is how I got these angles, also how I found this hypotenuse via just doing some math. So one of the first things you see, this is 17 inches, it's not your normal 24, and this is only 20 inches. You might be doing something a little bit different, and you may need to find out what this is without actually being able to measure it like I did. So anyways, how do we find this? All right, good old handy-dandy Pythagorean theorem here, and that's how you do it. One of the things I want to just remind you of is that this is going to be your long side, your hypotenuse. And whatever theta or phi you're looking at, whatever theta angle you're looking at, you always want to think about it as opposite, adjacent, hypotenuse. Angles here, well, what's the opposite board? That's your opposite. The short board that's attached to this angle is called your adjacent, and then this one would be, the long board is their hypotenuse. So ABC, all right? And so if we know, after going 14 inches or 17 inches minus our 1.5 inches that we have on our board here, we know we have a 15.5 inch stretch out all the way to here. Okay, what we do then is we square this, and then we square 20 inches as well, and then we take the square root of the sum of those. I would also mention you should really buy one of these calculators. You can get them at Walmart or maybe at Amazon for like $10, but they can help you out immensely, especially with fractions and adding fractions. And I'm going to show you a little bit here. Okay, you do fractions on this is this button here, this ABC. So 15 over 1/2 squared plus 20 inches squared equals 640 1/4. All right, and then we're going to square that, and we're at 25.3 inches. Well, 0.3, we don't, I mean, come on, we never work in decimals. All right, in tenths. We work in 16ths, 8ths, and 30 seconds, and so on and so forth. But anyways, I'm going to show you a really easy trick. A lot of times people go, well, 3/10, how do we do this cross product formula? Well, guess what? It's intense. We just do 1.6, right? I mean, if we're doing to 16, we just do what equals our 16th? It's 1.6. What equals our 8th? But when you go by a tenth, it's 0.8. If we want to go to 30 seconds, well, it's basically 3.2. So here, 3, all right, because I got that 3, 5.3. 3 times our 1.6 equals 4.8. It's pretty close to 5, so I just go 5/16. I know now that that's my cut. It's 25 and 5/16, and that's going to be my large side of my cut, the long side. But now how do I find these angles? All right, I'm coming off of the long side, going up on each direction. All right, so how do I find my theta? We're going to use our handy dandy trig function, tangent of theta. Tangent of theta, our opposite over adjacent. Our opposite is going to be 15.5 inches, and our adjacent is going to be 20 inches. All right, and then easy enough, we're going to go 15 over 1/2 inches divided by 20 inches equals 31 over 40. See how it gives you already? It gives you fractions. This is going to be really easy for you when you can do a whole bunch of job sites or try to figure out how much board you're going to need before you go and buy something. You can do 3/8, 5/8, and 5/16, and it's going to give you fractions back, so something you're more familiar with. All right, so anyways, we have 31 over 40, and then, but it's in tangent theta. We need theta. Well, you see right here how we have tan inverse, or arctan is what it's known as? We can just find this, tan minus 1 on your TI 30XA. Right here. And how do you get that green? Just second green. And then we have 37.77. That is our angle, 37.8 degrees. I showed you before on how to find other angles via using a speed square. All right, so now we know what this angle right here is. It's 37.8 degrees approximately. All right, and then what about this angle? This angle, opposite, 20 inches over adjacent, which is 15.5 inches, right? So we go 20 divided by 15 over 1/2 equals, and then same thing, second tan, 52.2. All right, that's your degrees right there, and that is going to be your degrees that you come off of here. So you're going to go 52 degrees from the long side of your board to the place you're going to cut off. Same with this is 37.8. You're going to go from the long side of the board, cut up into that, and then the rest goes away. Okay. Speed square technique as promised. Okay, so we know the first angle is 37.8. Notice that on the long side, I have my spine and I have it flush to where I'm going to cut, and then I find my 37.8, and then I rotate it, or I make a mark first, and then I rotate it, and then I draw my line, and then I make my cut down that line. And then you're just going to repeat the same thing with the other side, right? You come over, all right, and we make our cut like that. So we flip our speed square over so that the flat part's on the outside, and then find where we're going to cut, and then we find our mark. There's our 52.2. Put a stick or something out there and make a mark as you would at your 52.2, and then you just rotate it around, and then you make your line, and then you make your cut, and then you're going to get nice flush mounting points like this, and you're going to have a really nice strong shelf, and it looks nice and clean. And given the space, I'm happy with the build, and there's my shelf, what it looks like in the end, and I hope your project goes great.